Hello folks, so in this video, this is going to be actually quick and dirty. We're going to talk about angles and their measure in the coordinate plane. So we've drawn a lot of angles, especially in geometry, where they're just kind of like floating around in space here on your piece of paper. But now what we're doing in pre-calculus is we're gonna take those angles and put them in a kind of more organized fashion on our x and y axes. So let's take a look at Desmos to actually do this. Just note, this is what we're focusing on today, just seeing angles on the coordinate plane. In the next video, we'll talk about this thing called degrees and radians and how to switch between them. Okay, so here we are in Desmos. Okay, so I've drawn an angle here, and what we say is we'll always start one side of the angle on the positive x-axis. So this is just a ray, remember from geo. It starts off at the origin and points forever to the right. Alright, so now we call that purple side, that first side, the initial side. Every angle has two sides. We call the first one the initial one. Makes sense, I think, first and initial. So we call the second side, which actually tells you how wide the angle is, and we call that the terminal side. Alrighty, so I can't write that here, but I think you have that. We call this the terminal side. So notice, if we say that A is the angle, or the measure of this angle, then as I open up the angle, open up the terminal side counterclockwise, the angle goes up. And so that's how we have decided, we being mathematicians, I suppose, have decided angles are measured. And that we say we start off at 0, when that would be the positive x-axis, and then as angles increase, it opens up counterclockwise. Ready? If it opened up downward, well, this would be, we would just simply call it a negative angle. So if I wanted to say, let's extend this to, let's say if I want to go down to negative 90 degrees, that would simply mean I'm bringing this angle, that initial side, clockwise down here. Okay? Down here. So that's why our angle now is at 83. Okay. So we could also go further on this, and I'm going to have to kind of extend this. So pay no attention behind the curtain here. Oops. I have to extend this. Sorry. Stand by. Okay, sorry about that. But now you can see that I've made an obtuse angle now. So our angle measure is at 105 here. And so now we can keep going. And if we want to, we keep going forever and ever. So notice, again, as we go open this angle up to a 180 degree angle, it just looks like a straight line. But we could go further. And in geometry, we kind of, in most cases, we restrict our angles to between 0 and 180. And the reason we do that is because we usually work with convex polygons, right? Where there's no angles bigger than 180. But if I then draw it this way, now I have an angle, and again, this angle would be this one up top, and you can see my purple cursor here. It would be measured all the way from, again, the positive x-axis clockwise to wherever the initial or the terminal side ends. And so this angle would be 210 degrees. You can think of it as just 180 plus a little bit more, right? And then we could keep going all the way around until, sorry, I'm gonna have to go back to this one, sorry, until we get to, well, one whole revolution is 360 degrees, so that's why this goes up to 360 now. And you could keep going and keep going and keep going and keep going and keep going. And so this angle now, I've gone around, I think I kind of miscounted, but I've gone around at this point like 4 times, right? Or actually, I've gone around 4 times and then drawn it there. So if I was to actually draw this, and so this is what we'll do, is let's suppose I want to draw an angle of, let's say, 400 degrees. Okay, so let's actually draw this. So I'm going to draw my x-axis here. Or sorry, my coordinate plane. So here's my terminal side, remember. Sorry, words. My initial side, I'm going to draw in green. My initial side, that again is just the positive x-axis. That just stays there. Well, if I'm going 400 degrees, I know for sure I'm going around 1 revolution at least, right? So if I go all the way around here, so far that's 360 degrees. This is 360. But remember, you're going now, we have 40 more degrees to go. And so that would look something like, I don't know, I'll estimate it right around there. And so this is where our angle would end up. So this is 360 plus 40 more. And so in actuality, it looks just like a 40-degree angle. However, we know that, we behind the scenes know that it's gone around more than one. So it's actually a 400-degree angle. This is going to come up later when we actually talk about sine and cosine and tangent of these angles, because this is a little preview, we actually could just evaluate sine of 400 degrees. We just have to figure out what that means, and we'll get there in the near future.